In this video, I want to continue to talk a little bit about terminology having to do with vectors. Vectors can be described a couple of different ways. One way you can describe a vector is just using coordinates of points. So I might have a vector that goes from the point 1, 4 to the point, let's say 3, 8, something like that. Okay. And you could just plot those 2 points, and you'd be starting at this point. Your end of your arrow would end at that second point. Vectors very often, though, are represented in what is referred to as standard position for vectors. So this is a vector that starts out at the point 1, 4, goes over to the point 3, 8. It would look something kind of like that. Standard position for vectors is for the tail of the vector to be located at the origin. Okay. And so what I can do here is I can take this vector and I can basically shift it over and down to the origin, and I can figure out where would the head of that vector be if I shifted that over and down. Okay, well, if you think about it, if that's the point 1, 4, we basically need to shift the whole thing back 1 to the right, and we need to shift the whole. All right. And if you kind of think about that, really, then all that's doing, we'd be subtracting 1 from the 3, and we'd be subtracting 4 from the 8. Okay. And so 3 minus 1 is 2, 8 minus 4 is 4. And the new vector, starting out at the origin instead, basically shown in standard position, would end up going out to the point 2, 4. And so I could draw that maybe looking something kind of like this. Again, that's supposed to be at the origin there, going out to the point 2, 4. Okay. By the way, vectors very often, instead of using parentheses, which kind of looks like a point, a lot of times they're going to use brackets like this. You'll see a couple of different notations. A lot of times, maybe if I want to call this vector v, we might say vector v is equal to 2, 4. Okay, different books will use different notations, but that type of setup is pretty standard. Okay, so you're really just taking the second y, subtracting the first y, taking the second x, subtracting the first x. And by the way, this will work even if you have positive and negative signs or that sort of thing. This is still going to work the same way. Okay, follow up, the magnitude of a vector. If I'm talking about the magnitude of a vector, let's say I have the vector 3, 4, and I want to find its magnitude. So that's going out to the point 3, 4. You should be able to make a little right triangle. And we've got a right triangle with a side length of 3 and a side length of 4. And so hopefully you can see here that the magnitude is 5. Okay, that's really the Pythagorean theorem. I'm really taking that x side squared plus the y side squared and then taking the square root. And so the formula that we tend to use for the magnitude of a vector, if it's graphed in standard position, is that it's going to be the square root of the x coordinate squared plus the y coordinate squared. And by the way, the magnitude symbol looks like little absolute value lines. Okay, and the reason it looks like that, if you think about what an absolute value is, it's the distance from 0. Okay, we're on a coordinate plane now, but it's still basically the same idea. It's the distance from the origin. By the way, some books will use absolute value symbols. Some books will do kind of a double marking like that. They're the same thing, just you'll see slightly different notations in different books. Okay, but that's the basic idea of writing a vector in standard position and finding the magnitude.